Thank you very much. Like he said, I forgot your name, but I focus on control environment and sustainable energy, whatever that means. You know, when they advertised the position, that was the description, so I went for it. So today we're going to talk about growing plants indoors. And there is a lot of claims about sustainability. Some of them are true, some of them are not. But I'm not going to go there. I want to keep it on the upbeat. So we're going to look on a different area. So when I said indoor farming, you probably picture something like this, right? This is a farm in Indiana, Greensense Farms, or something like this. This is a farm in the Netherlands called Delicious, and they produce the lettuce seedlings in those compartments, and then this machine robot brings it out to the greenhouse to finish them. Or maybe you're picturing something like this, Green Spirit Farms. They're located in Michigan. A little less technology, but it's still considered vertical farm. Or you may consider something like this, a local, right? Based in North Carolina, crop box. They're producing leafy greens inside containers. When I think about vertical farming, I look at this. So this is what my research does. We look at all those components that allow plants to grow indoors and try to find interaction between them. However, you only need to remember 7 of these components, right? Light quantity, light quality, which is the color. We will need light quality to control the development and the morphology. Also temperature for the metabolic rate of the plant, right? Humidity to control the transpiration, right? We need also air velocity. We want to manage the leaf boundary layer to improve photosynthesis. Nutrients and water, and of course, atmosphere, the CO2. Only 7. But really, you don't have to remember any of them but light, because today we're going to talk about light. So why light? On a plant factory, 85% of the electrical consumption is used for the light to grow the plants, right? So to control the temperature, to remove the humidity, we only use 10% of the energy, right? So HVAC systems have become very, very efficient, so it's not such a big deal. To move the water around, to provide the plants with the nutrients, and to circulate air, we only need 5% of the energy. But again, 85% of lighting. Now with the new LEDs, I just checked yesterday, the most up-to-date efficiencies, we can knock that down close to 60%. So we're doing better. But what I'm trying to do in my lab, I'm trying to leave the same amount of resources going into the plant factory, but just change the color of the light, right? So we're going to probably spend the same amount of electricity, but I want to play with the colors of light to see if I can achieve something else. So here you have a cucumber seedling. We grow them under different percentages of red light and blue light, right? So the first plant over there is grown under 100% red light. Oh, give it away. Thank you. Okay, thank you. I told you to wait, okay? So you can see very here, if we increase the amount of blue light, we have a more compact plant. That's a desirable characteristic. We also went into those plants and measured the amount of photosynthetic rate, right? And we found that with the increase of the percent of blue light, you have more photosynthesis. But we also found that with the increase of percent of blue light, you have less growth, right? I know I was like, right? But anyways, we figured out why. It's because of the leaf area. Now, over here, we grow plants under 100% blue light, and I was going to expect a plant even more compact. But we even found something like this, right? So we moved the red out of the equation, and now we have a very stretched plant. And this plant has the same amount of growth that our best plant, which is 10% blue light, right? But it just went nuts. It went crazy. Stretch on the desirable plant with great growth rate. So we go ahead and investigate what happens to that. Now let's talk something more pertinent to food production. So this is lettuce. Grown on the same exact environment. The only difference is the color of light. Right? So what we're trying to do is try to find the light that will produce you the most fresh mass. Right? So when Whole Foods buys lettuce, they buy it by the weight. Right? So growers may want to trick Whole Foods and say this plant weighs more, so let's create a plant with more fresh mass. Those plants right there have the same amount of fresh mass. So what happens with fresh mass? Their cells have more water in it. Right? Now, I can tell you that this plant has the most anthocyanins, right? So the most nutrition plant is coming out for that plant that grew in that specific light recipe. But even to make it more interesting, that plant is the biggest plant. The most growth rate, the most cell, the most carbon sequester is on that plant, right? So even more than this one, and this one, and this one. So So these are just more stretched, right? So with the light quality, I can make plants stretch, or stir compact, or make them create or be more nutritious, just by changing the color and maintaining the same inputs, trying to help the sustainability. So another good example. So these plants were grown under white light, right? Fluorescent lamps. You have a couple, well, I'm sure that everyone went to LEDs, but just fluorescent lamps, right? So they grow under white fluorescent lamps, and a few hours before we turn the lights off, we provide them with blue light, or far red light, which is between 700 and 800 nanometers. Just a little bit of it. So we were able to increase the nutritious, 26% more anthocyanins, 12% more carotenoids, and a same amount of biomass and everything else than your control. Now with far red light, we actually decrease the nutritional capacity of that plant content, but we increase the growth. So what do we do? So let's do a combination, right? So now we don't have any effect, so we have the same amount of nutrition than at the control, but we still increase the growth rate. And I think the table there is looking for this, but since I grab it, I can, there is no triangle. Have way more slides. So what is the application of my research you want to put it into the entrepreneurship sector? So here I grew some tomato seedlings indoors, right? And we find out not only the perfect light recipe, but also the perfect combination of all the other environments, the seven that you're supposed to remember, right? So we find the perfect combination. And then a startup took that recipe and started producing grafted vegetable seedlings, right? So grafted plants, just like your wine that you like so much, they're grafted into a rootstock. We can also do that with vegetables, right? So what happens is that you create, you have your favorite tomato on top, and then you have your wild type tomato that has very crappy fruit, but great root system, right? So we grow them up to this size, we cut them in half, and we glue them together, right? So but there's difficulties on doing this. No, actually the cutting and putting together, that's easy, just tedious. But growing the plants to be at the same stage, so they're ready at the same time. So we found that recipe. And now these plants are substituting fumigation on tomato fields, because now you have a rootstock that is tolerant to diseases and pathogens. So what are the current efforts at NC State? So we want all those parameters that you talked about. We want to create a small facility that can serve us to train engineers and to train students and to train entrepreneurs on how to grow plants indoors, right? And it's not going to look like a building like that. It's probably going to look like a repurposed cold storage, or a garage, or even a shipping container. So I want to create that capacity for all of us to get to play with growing plants indoors. And that's what I have. And just click on it. Yeah, just click on it. Thank you. And I open the floor for any questions.